Here are some of the common aggregate functions. They are documented on the Discern Explore Help Wiki. I will provide some highlights. We can start off with the easy ones. The count function counts individual records within a specified break. It is simply the number of rows. 8 in this example. The min function returns the smallest value of an expression across a specified break. 7 here. The max function returns the largest value of an expression across a specified break. 45 here. The sum function returns the total value of an expression across the specified break. 206 for this data. The average function returns an average value across a specified break. 25.75 here. The percent function returns the value from the result set where 50% of the values come before the returned value. Or, worded differently, you will receive the value at the 50th percentile. This function is only available in the report writer sections. This function can be used with the percentile function to allow setting a different percent breaking point to capture a different percentile. In this data, there are 8 rows. 50% of those rows is 4. So the percent function would return the next value, which is 29. The median function returns the middle value of the aggregate list. If there's an odd number of results, then it is the result in the middle. In this data, since there is an even number of values, the median falls between 2 values. When that happens, those 2 values are averaged to get the median value. 27 for this data. The variance function returns the variance of an expression that is an integer or real number across the specified break. This one's a little more difficult to break down, so I'll show you the formula used to calculate it. That yields 203.93. The standard deviation function returns the standard deviation of an integer or real number expression across a specified break. This is basically the square root of the absolute value of the variance. Here's the formula used to calculate it. That is 14.28. Aggregate functions can be used at the end of groupings in Report Writer. That would be the foot sort item and foot report sections, since those sections are at the end of a grouping. If you want to count all orders on a report, then the count function can be used in the foot report section. Or, if you want to count the orders for a specific person, then the count can be placed in the foot person ID sort item section to apply the aggregate to just that grouping. You would not want to use an aggregate function in the foot page or any of the other report writer sections, as they are not at the end of a logical grouping. If you did use an aggregate function in any of those other sections, then you would not get the expected results, since they would not have access to data for the entire logical grouping. Most aggregates can be used in a simple select or a more complex group by having query. Another aggregate option is the OLAP expressions or online analytical processing. We'll unpack what it looks like to use aggregate functions in the various methods above. Let's start off with seeing their use in Report Writer. Specifically, we are using aggregates in the foot sort item and foot report sections. In this select, we are capturing gender data and a number that represents how many days back since the data was updated on the person table. We have a foot sort item section of sex disp. This will process one time for each gender returned in the results set. This section forms a logical grouping for each gender. If the first gender processed is female, then this section will be looking at just the data related to females. We'll have a couple of aggregates here. The first one is count. It will return the number of rows for the gender that we are currently on. This example, there are 53 females in the results set. Remember that the .seek field is available on all Millennium tables as an easy field to apply an aggregate to. However, it is only known at the Discern Explorer level. We also are using the average function around the days diff expression to allow us to see an average of how many days it has been since all the rows have been updated for the gender that we're currently on in the results set. In this example, that would be 473 days on average since those female rows were updated. This sort item section will be processed for all other genders returned in this result set. We can see that the results were returned for males as well. There were 47 males that were in the result set that were updated on average 455 days ago. We also have the foot report section used. This will have access to all the data from the report when it comes to applying the aggregates. We are using the count function to get a total count of all people that qualified in the result set. We can also add a qualification to limit the data that the aggregate function is applied to. Here's an example for the fem variable that is applying the count function for only those that have a sex code of female. Thus, we are only going to get a count of the number of females in this result set. We are then going to display that value. We will also use that value in a calculation to find the percentage of how many females there are to the total count. We'll then multiply by 100 and display with % after it. In this case, we have 53 females in the result set, which accounts for 53% of the entire result set of 100. We can also use aggregates in the select list of a simple select. This use can be good for information gathering and troubleshooting. These will return aggregate data for all rows that qualify. An example would be select count star from the encounter table. This will return a count of all rows on the encounter table. There are a couple of options for what we can include as the parameter that will flex how this aggregate is applied. This example uses an asterisk, which will include nulls in calculating the aggregate. This will count all rows on a table, regardless of whether certain fields have data or not. The other option is to use an expression. An index field would be recommended as the optimizer can more efficiently get the desired information than from a non-indexed field. When using a field, the aggregate does not include nulls from that field. Let's expand our example a little further. Instead of using count star, we can use count encounter ID. This will return a count of all non-null rows for that field. Remember that the encounter ID is a unique identifier and primary key on the encounter table, so it should always have a value in it. I would expect this count to be the same as count star. Now, if we look at a field that is not expected to always have a value in it and wrap an aggregate around it, we would see a different value returned. say we use the count aggregate against the discharge date time field. This field would only be populated for encounters that have been discharged. For active encounters, this field would be null. Thus, they would not be counted. We can take our simple select aggregates a step further by adding in qualifications to limit the data returned to focus in on just the information that is relevant to the actual data that we are after. The next example is using the count star from the personnel table with a qualification of physician indicator equal to 1. This will return a count of rows where the physician indicator is equal to 1. Or, to say a different way, how many physicians are in the personnel table. We can also include multiple aggregates in the select list. This next example uses the max and min aggregate functions wrapped around the original order date time field from the orders table for a specific encounter ID. This will look at just the rows on the orders table for encounter ID 589805, then at the smallest and largest values of the original order date time field. Remember that the date time fields are stored as a number, so the smallest is the oldest and the largest is the newest original order date time for that encounter. These values are then returned as a number, so a mask would need to be applied for Discern Explorer to display these values as dates. Another option available is to use the group by clause. This can be used in conjunction with aggregate functions. Some common ones that are used with the group by are count, max, min, and sum. Group by allows us to group rows of data into summary information. Rather than pulling back one number for all rows that qualify in the result set, you can have multiple rows with summary information based on the group by expression. The group by expression defines how the rows are to be grouped together. This group by would group the data by nurse unit. When using the group by clause, we are limited to select expressions that are constants, aggregate functions, or expressions from the group by clause. The group by follows the qualification section of the select. The group by can be placed in parent queries or in nested selects. When used in a nested select, an aggregate with a group by can help us qualify on specific data that our parent query can then expand on. An example of a use in a nested select could be the max on a date time field, like the original order date time field on the orders table to get the most recent order for each person. Here's an example demonstrating the use of the group by clause. We are specifying that we only want active encounters by qualifying on the discharge date time field equal to null. If the encounter has not been discharged, then it is still an active encounter. We are then grouping by the loc nurse unit code so we can see the count broken down by the nursing unit. Notice that we limited our selection list to just the group by expression in an aggregate. If you wanted to add additional fields to the select list, then they would need to be added to the group by clause, which can change the grouping and thus how the aggregates are calculated. We can see that the nursery has 56 active encounters or patients. We can see that oncology has 3 patients and cardiac rehab has 11 patients. Let's say we're only interested in some of this data, particularly the larger populations. We could use the having clause to help us designate what we want to see. Often used in combination with the group by clause is the having clause. The having clause restricts rows returned from the group by clause. Here's a breakdown of the order of operations as to where various qualifications or restrictions are applied. We start off with our qualifications in our where clause. Groups are formed by the group by clause. Then, the having clause will only display those groups that satisfy the condition. The group by and having clauses are only applied to RDBMS queries. There is no equivalent from the Discern Explorer side. Let's see what using the having clause would look like. Here's the same query and the same results as what we just saw. Let's say we're only interested in seeing those units with a patient count greater than 10. The row for oncology that has just 3 patients would need to be removed from the result set. We can add in our having clause with our count greater than 10. The having clause allows us to see just those results where the count is greater than 10. This could be helpful if you had some outliers or other insignificant data that you wanted removed to allow the end user to see only the relevant data that they are after. For this class project, we will create a query that will show the IDs and names of people and the encounter count for those whose personal information has been updated in the past year for only people that have had 2 or more encounters registered in the last year. Let's jump into DVDev to build this out. We'll start off with a new query in Query Builder. We will need the person and encounter tables. Then to the Fields tab. From the Person table, we'll need the Person ID. And the name full formatted. For our count, we can use the Add Expression button. We can then double-click on the Count function in the Functions list. With the Function Builder box checked, this will open that function in the Function Builder. Expression name can be our tote encounter. We can count the encounter ID from the encounter table. Okay, that looks good. Now to the qualifications. We can start off with our requirement to get people who have been updated in the past year. Then join to the encounter table and link it to the person table on the person ID field. We also need the encounters to be registered in the past year. That should take care of our qualifications. We're going to need a group by, and we can do that in the Group By tab. We can check the Include Group By checkbox to add in the group by. Notice that add the person ID and name full formatted fields to the Group By pane. Basically, Query Builder pulled over all the items in the select list that were not an aggregate expression. We could also add in the halving clause using the halving pane in this window. We will hold off on that for the moment and add it later. Let's add a few control options. Max rec of 100, time equals 30. Notice that Query Builder added in the group by clause after the qualifications, but before the with clause. Query looks good. Let's run it and see what we get. In our results, we have a bunch of people that have just one encounter. Let's go back in and add in our halving clause. We want our count to be greater than 1 to capture our 2 or more requirement. Notice that the halving clause was added after the group by clause. Let's run this again to see what the output looks like. Looks good. We see only people that have 2 or more encounters. If we want to see the person with the highest number of encounters listed first, we can do that by sorting the data. We can add that in the Sort tab, then bring over the Count expression, and then select Descending for the sort so the highest numbers are listed first. Notice that the order by clause follows the halving clause. When we run this, we can see the highest number of encounters listed first, followed by the lower numbers in descending order. We used Query Builder to build out this example. However, it could also have been done in a blank document by manually typing in the commands.